You were probably taught that Pluto is the coldest place in the solar system. At an average distance of about 5.9 billion kilometers from the Sun, with surface temperatures around 220 degrees Celsius, 364 degrees Fahrenheit. That seems logical, but it's not correct. The coldest temperatures ever directly measured in the solar system are not on Pluto, and they're not in the distant Kuiper belt. They're much closer to home, on our own moon. Inside permanently shadowed craters near the lunar South Pole, sunlight has not reached the surface for billions of years due to the moon's slight axial tilt of only about 1.5 degrees. In 2009, NASA's Lunar Reconnaissance Orbiter measured temperatures inside some of these craters dropping below 248 degrees Celsius, 414 degrees Fahrenheit. That's colder than Pluto's average surface temperature and comparable to some of the coldest environments known anywhere in the solar system. These regions are so frigid because there is no atmosphere to trap heat and no direct sunlight to warm the surface. The darkness is permanent, and thermal radiation slowly escapes into space without replacement. Water ice has been detected in these shadowed craters, preserved in deep freeze for billions of years. The coldest known place in the solar system isn't on the edge of the Sun's domain. It's hidden in eternal night, just 384,400 kilometers away. Pluto is freezing, but not the coldest. Pluto's average surface temperature is about 229 degrees Celsius, 380 degrees Fahrenheit, making it one of the coldest known planetary bodies in the solar system. Orbiting between roughly 30 and 50 astronomical units from the Sun, about 4.5 to 7.5 billion kilometers away, Pluto receives sunlight that is nearly 1,000 times weaker than what Earth receives. At those distances, the Sun appears as little more than an intensely bright star in its sky. For decades, it was widely assumed that Pluto held the record as the coldest place in the solar system. However, detailed temperature measurements from spacecraft and remote sensing instruments revealed something surprising. Data from NASA's Lunar Reconnaissance Orbiter, which has been mapping the Moon since 2009, showed that certain permanently shadowed craters near the lunar South Pole reach temperatures below 248 degrees Celsius, 414 degrees Fahrenheit, colder than Pluto's average surface. These craters never receive direct sunlight due to the Moon's minimal axial tilt of about 1.5 degrees, allowing heat to radiate into space without replenishment. While Pluto remains an extraordinarily frigid world, it does not hold the absolute cold record. The coldest measured temperatures in the solar system are found much closer to Earth, hidden in permanent darkness on our own moon.
The Moon's shadowed craters. The coldest known place in the solar system is not on Pluto or in the distant Kuiper belt. It is found much closer to home, inside permanently shadowed craters near the Moon's South Pole. Measurements from NASA's Lunar Reconnaissance Orbiter (RO), launched in 2009, recorded temperatures as low as about 248 degrees Celsius, 414 degrees Fahrenheit within these regions, colder than Pluto's average surface temperature of around 229 degrees Celsius, 380 degrees Fahrenheit.
The reason is geometric and atmospheric. The Moon has an axial tilt of only about 1.5 degrees, so near its poles, sunlight skims the horizon and never reaches the deepest crater floors. With no atmosphere to scatter or trap heat and no direct sunlight for billions of years, these areas radiate their thermal energy into space and remain in permanent darkness.
Some of these craters have likely been shadowed for over 2 to 3 billion years. The extreme cold is sufficient to trap volatile compounds such as water ice, carbon dioxide, and even other frozen gases delivered by comets and micrometeorites. These ultra-cold cold traps represent some of the most thermally isolated environments known in the solar system, proof that the deepest freeze is not found at the outer edge of the Sun's influence, but hidden in eternal shadow just 384,400 kilometers from Earth.
Why permanent darkness matters. On Earth, even the Arctic and Antarctic experience seasonal sunlight because our planet's axial tilt is about 23.5 degrees, allowing the Sun to rise above the horizon at different times of year. The Moon, however, is tilted by only about 1.5 degrees relative to its orbit around the Sun. Near its poles, sunlight skims the surface at extremely low angles. Deep impact craters in these regions can block that grazing light completely, leaving their floors in permanent shadow for billions of years. With no substantial atmosphere, only an extremely thin exosphere, the Moon cannot trap or redistribute heat. There is no air circulation, no greenhouse effect, and no weather system to moderate temperatures. As a result, these shadowed crater floors continuously radiate their residual thermal energy into space and receive virtually none in return. Measurements from NASA's Lunar Reconnaissance Orbiter have recorded temperatures dropping below 248 degrees Celsius, 414 degrees Fahrenheit, in some of these cold traps. These conditions are so extreme that they rival or even undercut the temperatures of many distant solar system bodies. No sunrise ever reaches these regions. No seasonal warming occurs. They remain in perpetual darkness, stable, ultra-cold environments preserved colder than outer planets. Even Neptune, orbiting at an average distance of about 30 astronomical units from the Sun, roughly 4.5 billion kilometers away, has average cloud top temperatures near 214 degrees Celsius, 353 degrees Fahrenheit. That is extraordinarily cold, yet still warmer than the lowest temperatures measured inside permanently shadowed lunar craters. The reason comes down to atmospheric physics. Neptune possesses a thick atmosphere composed primarily of hydrogen, helium, and methane. This atmosphere traps heat and redistributes energy through winds that can exceed 2,000 kilometers per hour, the fastest recorded in the solar system. Neptune also emits more internal heat than it receives from the Sun, which further moderates temperature extremes. The Moon, by contrast, has virtually no atmosphere, only an extremely thin exosphere incapable of trapping infrared radiation or circulating warmth. In permanently shadowed polar craters, sunlight has not reached the surface for billions of years due to the Moon's minimal 1.5-degree axial tilt. With no atmospheric insulation and no direct solar input, heat radiates freely into space. As a result, temperatures inside some of these craters drop below 248 degrees Celsius, 414 degrees Fahrenheit, colder than Pluto's average surface and colder than Neptune's cloud tops. The absence of an atmosphere, not just distance from the Sun, is what allows the Moon's water ice hidden in darkness. These ultra-cold lunar craters are not just record holders for low temperatures, they are also long-term storage vaults for volatile materials. Temperatures below 248 degrees Celsius, 414 degrees Fahrenheit, are cold enough to prevent sublimation, the process by which ice turns directly into vapor in a vacuum. In most sunlit regions of the Moon, exposed water ice would quickly sublimate due to solar heating. But inside permanently shadowed craters near the poles, the extreme cold allows water molecules delivered by comets, asteroids, and micrometeorite impacts to accumulate and remain stable for billions of years. Data from missions such as NASA's Lunar Reconnaissance Orbiter and El-Cross Crater Observation and Sensing Satellite have provided strong evidence of water ice mixed within the lunar regolith in these regions. Some estimates suggest significant deposits may exist, potentially amounting to millions or even billions of tons in total across both poles. This makes the coldest place in the solar system one of the most strategically important locations for future exploration. Water ice can be converted into drinking water, breathable oxygen, and hydrogen fuel for rockets through electrolysis. Because launching materials from Earth is extremely costly, in situ resource utilization on the Moon could support sustained human presence and deep space missions. The darkest, coldest craters, frozen in silence for billions of years, may become critical hubs for humanity's next steps beyond Earth. Spacecraft confirmed the measurements. The Lunar Reconnaissance Orbiter's Diviner instrument directly measured these extreme temperatures. This wasn't theoretical modeling, it was real thermal data. The readings surprised scientists because they were even lower than some predictions. The Moon, often considered geologically quiet and simple, turned out to host the most extreme cold environment ever recorded in the solar system. Why Pluto isn't as cold? Pluto actually has a thin atmosphere composed mostly of nitrogen. Even though it's extremely tenuous, that atmosphere can help moderate temperature extremes slightly when Pluto is closer to the Sun in its elliptical orbit. Meanwhile, the Moon's craters are airless and shielded from sunlight permanently. Darkness plus no atmosphere equals record-breaking cold. Cold traps across the solar system. The concept of cold traps exists elsewhere too. Mercury, despite being closest to the Sun, also has permanently shadowed polar craters containing water ice. Like the Moon, Mercury's near-zero tilt allows some regions to remain in eternal shadow. These cold traps demonstrate that temperature in space isn't just about distance from the Sun, it's about sunlight exposure and atmospheric presence. The physics of extreme cooling. Objects in space lose heat by radiating infrared energy. In areas that never receive sunlight, there is no incoming energy to replace that lost heat. Over billions of years, temperatures can drop to incredibly low levels. In lunar cold traps, surfaces approach temperatures not far above absolute zero, 273.15 degrees Celsius. The coldest place is closer than you think. The most shocking truth is this: the coldest place in our solar system isn't billions of kilometers away. It's about 384,000 kilometers from Earth, a location we can reach with current technology. The Moon, our familiar companion in the night sky, hides regions colder than Pluto, Neptune, or any distant dwarf planet. The coldest place isn't far away. It's been orbiting us this entire time. Pluto feels like the obvious answer when asking about the coldest place in the solar system. It orbits billions of kilometers away, bathed in sunlight nearly 1,000 times weaker than what Earth receives, with average surface temperatures around 229 degrees Celsius, 380 degrees Fahrenheit. But the universe rarely rewards assumptions. The coldest measured temperatures are not on Pluto or in the distant outer planets. They are found much closer, inside permanently shadowed craters near the Moon's south pole. Data from NASA's Lunar Reconnaissance Orbiter have recorded temperatures dropping below 248 degrees Celsius, 414 degrees Fahrenheit in these regions. Because the Moon's axial tilt is only about 1.5 degrees, sunlight never reaches the deepest crater floors. And with virtually no atmosphere to trap heat, thermal energy radiates directly into space. Some of these areas have remained in darkness for billions of years, creating stable cold traps capable of preserving water ice over geological timescales. Even Neptune, far beyond Pluto's orbit, has cloud-top temperatures around 214 degrees Celsius, 353 degrees Fahrenheit, warmer than these lunar shadows. The coldest place in the solar system exists not at its edge, but hidden in eternal night, just 384,400 kilometers away.